Hello, so today we are going to do this Leetcode, part of Leetcode April challenge, recover binary search tree. So the problem says we get a root of a binary search tree, and the values, and we have two nodes of the tree that are swapped by mistake, and we want to recover the tree without changing its structure. So basically here 3 is and 1 are not in order, 3 and 2, so it's not always the parent and the child. So I'm thinking maybe if we do in order traversal, and for in order traversal the previous value has to be smaller. So 3, the previous value is, for 2 the previous value is 3, so the previous value has to be smaller, so we can maybe keep track of the previous value in order and keep track of the so I'll write it iteratively, I think, because just it's easier to do that with that. So I have stack, and then I need current to be root, and well, stack, this is just the template of in order traversal. Let's make this bigger. Okay, and now we want to go all the way to the left, so that will be current equal to current.left, and then we want to push the node, so this would be append current. And now here we are in the processing phase, so we need to assign prev equal to current, and we need to assign to current.right, and then here we need to check, and I need to assign prev, so prev equal to none. Okay, if prev, then I will need to check if prev.val is, so the previous value should be smaller. If it's bigger or equal to the current value, then we need to recover, so we need to switch current is equal to current. We need to switch the values actually, so prev.val and current.val is going to be equal to prev.val. Okay, and then we do that, and I think that should be it. Does it say that there is only one? Exactly 2 nodes, so only one, so we can return here. Let's try. Before assignment, really? Oh, equal, yeah, sorry. Okay, why? Oh, we didn't pop from the stack. That's bad. So we need to pop actually. Here we should pop, because otherwise current is empty. Okay, looks like I swapped 3 and 2 instead of swapping 3 with 1. Should be before. No. Okay, why is it swapping 3 and 2 instead of swapping 1 and 3? Okay, let's see what it detected here. So if you take a look here, 3 and the current node is 2. Okay, 3 is the wrong one. 1 is before it. It's not the current that I should swap. So here I'm swapping because prev is 3. It's bigger than 2, but that's because it's out of order with 1. I should have detected that 1 is smaller. That 3 is bigger than 1. So current bigger than prev. Okay, this is on the left side, I think. So here, if current, if prev and current one should be smaller, so if it's bigger or equal to the prev value, right? So the reverse, right? So if the previous one is smaller or equal than current value, then we need to swap and return. Still it. Okay, I didn't assign previous here. So previous here would be equal to okay. Okay, what's the problem with the second one? So the second one, it's 3 and 2 are out of order. So here we find that 1 and 1 is out of order. Okay, that's messed up. Okay, so that's because it's from the previous value. So maybe I could separate them. Let me try that. Okay. Right, and then previous height. So it's saying 1 and 4 are out of order. Okay, let's go back to one prev and just print to see why there is a problem here. Normally this should work without this, right? It should work without this. It should be, because here we would have put the element in a sorted list, and what's after 2 is 3. And so, okay, let me just put here print processing current equal to and then val equal to prev equal to. Okay, so the previous value is 1. This is for this tree. The previous value is 1, and then the current value is 4. And 1 smaller than 4, that's where it should be. The problem is, okay, the problem is, why are we, is my code for in order even true here? Let's see. So let's have the values just to debug, and let's append here. Let's not do return, and I'll just append current.val, and I'll print that at the end. Okay, just to see if my in order has a problem. I'll give it a sorted one, or yeah, let's just give it this. Okay, this is prev. Okay, so the value is 1, 3, 2, 4. It's not the previous value. Okay, is this the second example or the third? This is the second example, yep. So 1, 3, 2, 4. Okay, so my in order traversal is actually correct. However, and the 2 that should be out of order are 3 and 2. Okay, maybe we could just do this actually, so let me try that. So if we don't do this even, so let's just get rid of this, comment these, comment the prev, change, and now here we get values. Okay, so we just go in a range of I1 to the length of values, and then we check if values at I-1 is bigger or equal than values at I. Here I'll add the nodes so that we can swap them. That val, if it is, then I want to swap. It's going to be equal to the reverse. Here, this would be I-1, and this would be I. Okay. Okay, that seems to work. No, looks like it doesn't work for the first one. Let's see. Okay, let's print values. So the traversal here should be okay. Let's print actually with mapping. Okay, x dot val for x in. Okay, so the values are 3, 2, 1, and we'll see that 3 and 2 are out of order, so we'll say, okay, let's swap 3 and 2. But that's not right, we need to swap 1 and 3. Okay, what if we just go from the back? Okay, this would be 0 here, or -1, and this would be 2, and we'll check I against I plus 1. So if the value here, so if the value in the next position is smaller or equal, then we have a problem and we need to swap. So basically at 1 and 2, 0, 1 and 2, we should stop here. So it should swap 0, 1, 2. So it should swap these two, 1 and 2. But I wanted to swap 1 and 3, so that's the problem. Yeah, okay. I think this approach will work. Okay, so I think from this it tells us that for our example here, we need to swap the last with the first. And in other cases we had them next to each other. So either they are next to each other, or in this case, first and last. So what I think what I will do here is out of order, right? List, and then get back to this. Remove values here. Remove this. Do the same thing that we did before, except here we'll do out of order, and we'll add both pref and current, right? And now we should do a return. We'll just add them, and then after the while loop, we'll swap. We'll swap this, the first one. So first, I can do first here. First and then last is going to be equal to that, and then this -1, and then I'll swap those, the values of those. So last.val is equal to last.val and first.val. Yeah, so it has the previous and current. So what do I need here? Okay, I think I need, for the first, I need the first, and for the second, I need the current. And then from that we should have, if I use all example test cases. Okay. First and last, so that it matches getting the first parent, getting the parent in the node. Okay, so if I submit this, okay, that works. Yeah, honestly, I don't have a good way to prove it, but okay, so from this it seems like we need to obtain the first and the second one to swap. And so I wonder if we can do this with just two variables instead of doing this entire thing, right? So we can do maybe have prev, but instead of this have first and last. And they start out as like this. And now here I will do, instead of doing prev, I will do if not first. Then I'll assign to first prev. Now if first, and we have this, then the second one is going to be prev, and then at the end I'll swap. Would this work? Okay, of course, if prev, so we always we check if first value, prev value is bigger. So if we make it float negative, then it will never be bigger. Okay, tree node. So it shouldn't be equal to the previous element here. It should be equal to current. That's what we are doing. That's what we did for the append for the previous version, the out of order. Okay, this does seem to work. Cool.